Please and please, let's understand this too. Gradually. You know, the data will come in a way that you don't like, isn't it? So if you don't understand how to manipulate these nitty-gritty data structures, it will not be good for you. So when working with data sets, we need to use data structures to store and manipulate the data. And R provides a number of data structures that provide functions to manipulate and manage the data they store. So let's start with one of the simplest data structures that you have been using, that's strings. And let's see how we can manipulate strings using the paste function, which allows you to combine multiple strings into one. So you can, if you want to combine strings together, there is a function called paste. Okay. So this is a string, yeah, because it's enclosed in. This is also another string. This is also another string. If you want to combine the strings together, in Python you can just use plus and add them using what we call concatenation. But in R, you have to use this paste. Example. If you say x is Python, let me see article or program, and then y is in R or R, isn't it? In Python, you can simply just come and say x plus y, and it will combine it together for you. But in R, you have to use the paste function, isn't it? Just use the paste. Okay? You paste x and y, and then you see what? The combination of x and y. Okay? It's clear now? And these are the paste function uses a space as a separator by default and can take any other parameter, isn't it? Understand? Using the sep parameter. Is it clear? You know, if I say x is, let me say x1 is Yusuf, x2 is Haruna, and x3 is James. If you come and see y is paste x1, x2, x3, isn't it? And you run this, and sorry, when you print ago, and you print what? You print y. You see what? Haruna. Sorry, x1.
X2.
You see Yusuf, Haruna, James. But by default, what's in between here? A space, isn't it? If you need something else, you can specify. But by default, you can just come here and say, please paste x1, x2, and x3, and the separator should be an asterisk. The separator should be an asterisk. Then if you run this, you see Yusuf asterisk, Haruna asterisk, James. It's clear now? Set as a separator, huh? It's clever.
Yes.
So this is an example. If you use dash, you have dash. So this is called concatenation in R. And in fact, there are several functions that you can call on. There are several functions that you can call on a string. For example, to lower. Let's not waste time here. to upper to lower. If you have a string and then there are functions, so you simply supply whatever you have. And so for example, you have a text here, hello, and if you want to convert this text to uppercase, what do? You simply call the upper function and you supply in the text, and then it becomes capital hello. And then if you have the text in uppercase, the text is now uppercase. If you now convert to lower, it becomes to upper to lower, to upper to lower. This is very useful, maybe for outputting some, you analyze data and there's a requirement that maybe the names should be in uppercase. You can just extract the columns and then before you print it, you call the to upper function, isn't it? So another useful function is the substring. It is used to get, it's like indexing. It's used to get substring from by using a start and end index. For example, if we have programming and we say we want you to print from the 5th string to the 9th string inclusive. So this is 0, 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Isn't it? So it starts from the 5th one and the 9th one, and this inclusive of the specified numbers. It's clever. It's clear. Substring is a function that helps you index strings. The next data structure is vector. A vector is this one is very important too. It's very, very important. You have to understand what it is and how you use it. A vector is a basic data structure in R, and it is because your data usually comes in tables, isn't it? Yes. And whenever you want to manipulate any column, you extract that column as a vector and then apply whatever you want to apply. Because a vector mathematically is just a one-dimensional array of numbers, isn't it? And your column is a multi-dimensional. So if you extract a column or a row, you extract that as a vector, and then you do whatever you want to do there, isn't it? So a vector is a basic data structure in R. It is a sequence of elements of the same type, and for you to create a vector, you use this C function, and then separate the elements by comma. For example, if you want to have a vector of 3 names, you have C, James, Amy, and John, isn't it? And then thereafter, so for example, you have x is equals to C 2, 3, 5, 6, 7, isn't it? And then you can see you want to get the max of x. So or the mean of x. So this could be a column, isn't it? So please get me the youngest applicant in this list. You just go and extract the column for the ages, and then you find the mean, isn't it? You know, maybe you're given a table of applicants, and then you are asked to tell who is this youngest, isn't it? And maybe it is 10,000 names. You cannot be scrolling, and you just go and extract the column for the age as a vector, and then you call in the something like that. You can also index, isn't it? You know, for the string, if you want to index, what do you use? You use the substring, huh? For the vector, if you want to index, you can use the square bracket. Okay? So if you say print names, the second name, so you just supply the name of the vector and then you supply in the index. So this is the first name, this is the second name, this is the third name. So this is Amy. Okay? So note that index in R starts from 1 instead of 0.
Sorry,
so,
sir.
Yeah.
In that very, in this last case, no need of curly bracket?
No. No need of curly bracket. You only use curly bracket when you want a control over some code, either in an if statement or for loop, while loop, or creating a function. But when you want to declare a vector, you simply use this. So when creating a vector, we can also define the character indices for the element in addition to the numeric indices. For example, you can have, if you just have the names like this, it's assuming that these are the elements, isn't it? And if you want to index it, you index by the counting, right? The first one, second one, third one. Just like we did when we did switch. If you leave it blank, it starts from 1, 2, 3, 4. But if you give them names, you can index by their names, just like we have it here. In this case, we're saying James is 18, Amy is 14, and John is 64. So if I want to get the age of James, I don't need to go and say ages 1. I can just specify the name and get the age, isn't it? It's clear now. If we want to output only the values of that index, we need to use double square, isn't it? So we can use the negative index to skip an element in the vector. For example, this will skip the third element of the vector. So if you say names is James, Amy, and John, and you print names minus 3, you are saying print everybody except what? Except John. Is that okay? You are saying skip everyone, print everyone except number 3. So let's try this. Let's see the names is equals to, it's a vector containing 3 names. You can say names, and the name is this one is how many? What do we give him? 18, but 18, and then Amy is 12, and then Sunny is 18, isn't it? Is that okay? If I come here and I say names, if I do names James, right? So I want to simply get the age of James, isn't it? That will be what? That will be 18. But when I print, what do you notice?
James 18.
Both the name
and
the age. If I simply want to get the age, I will use 2 square brackets, and it will only print 18 for me. It's clear, right? It's clear. What will happen if I come in and say 2? It will still give you the James and Amy. Yeah, it also works with the index, isn't it? But if you declare it already, then there's no problem. But then if I come here and I say if I say print names minus 2, what happens? It prints James and Sunny. Okay. If I do, it will give you error. This does not work. So we can also specify a range to select only a subset of the element. We use substring in strings. Here we have to use the index, isn't it? If you use 2 to 4, it gives you Amy to Dave, but is that no 4? 1, 2, 3, 4. To do Amy, John, and Dave.
2, 3, 4. Okay, yes. 2, 3, 4. Yes.
1, 2, 3, 4, 5. Isn't it? Yes. So from one, no, from 1, yes. It's from 1. Indices in R starts from 1 instead of 0. Those at the back, they are not contributing. Sir, there's a quiz for you. Yes, yes, sir.
Your last example. James,
Yes?
the use of the double.
Yeah, if I say here, if I say James, it means I want to get the age of James, right? It gives me 18. But in the output, it both me both the name and the what? Age. If I'm only interested in the number, I will simply come here and put double brackets. And then it will be only 18.
So,
Okay. If you run a code and it gives you error, please don't freak out and say it's not working. Just calm down and look at the error message. You will see where the problem is. For example, look at it. I come here and I put another bracket here. Huh? What's the error? I only added something. Just run the code and see. What was it? I want something that will give me error. Maybe.
Use 1. Use the.
Yeah.
Casas, just put
What's the problem?
dash L or
It's still even from here, man. You can.
right here.
Yeah. You know, R is friendly with errors. It's friendly with errors, so you can make error, and then it will still assume that okay, this is what this guy, and that's why I prefer. But for example, if I put name here, if you run this, you see it's still, even though maybe, it's still just replicating what you. Anyway, you understand what I mean?
Yes.
If you see an error, just calm down and this one that is refusing to even give error. Sir, this question is for you. Next time. So n is a what? N is a vector, isn't it? Containing 5 elements, 8, 4, 2, 3, and 5, isn't it? And then what's happening here? We are now indexing the vector n, but we are only interested in extracting the second through the fourth number inclusive, isn't it? So we have 1, 2, 3, 4, 5. So we have 4, 2, 3, right?
Yes.
So x will be 4, 2, 3. We now said, please, for x, ignore the first number. So it will be what? It will be
4, 2.
It will be
4, 2, 3.
2, 4 will be 4,
Okay, 4,
2,
2,
3.
5.
If you ignore the first number, it will be 2, 3. And then you are now printing the first number. It will be what?
Okay, we are now not referring to the main numbers. We are just looking at the results.
That's the result.
Okay, fine.
Yeah, look at it. This, C, n is a vector containing 8, 4, 2, 3. That's why we have n here now.
Yes.
We are saying from n, pick only the second through the fourth number. That's 4, 2, 3.
4, 2.
And keep it inside x. So x is now 4, 2, 3. We now said in x, remove the first number, 2, 3, and keep the result in x. So x is now 2, 3. We now said in 2, 3, what's the first number? 2. So the answer is 2.
No, sir, but the ratio is a phone, index 49.
Eh?
2 index, the is index 4.
Mm.
So it
Index
is-
4. No, index 4. Like index 4. One is we are indexing.
2 ratio 4. Sorry.
Who taught you that one?
I thought we are starting with 4, 2, then count 4. For example, 4, 2, 3, 4.
This 1,
Mm-hmm.
2,
Uh-huh.
3, 4, 5.
5. Uh-huh.
So this
now,
we are starting from 2,
2
and ending in 4.
in 4 years.
So 4, 2, 3.
Okay.
So x here after running this code will be what? X will be equals to what? 4, 2, and what? And 3, isn't it? And then we now said, okay, ignore the first one. So this guy goes, but it becomes what? 2, 3, and we keep it in x. And then we now say, in 2, 3, what's the first number? The first number is 2. So this is the answer.
Excuse me, sir.
Yes, sir. Yes, sir.
What if you have double 2? I mean, all the second and the third
Are 2.
are 2s.
Yeah,
Does it confuse you?
No, it doesn't matter. It won't even go to the second one.
As
What
in-
it's concerned is just the
As
first.
in names, maybe you have it 2 names. Here are numbers.
Mhm.
As in maybe you have
Even in the names, it goes to the index and just picks up whatever it's. Yes. Yeah, before that. No, not the first appearance. It goes to the index and picks up. If you have Yusuf, and you say x is x1, it goes to the first one, which is Yusuf, and picks it. Yes, sir.
So this arrangement now
Mm.
is not the Fibo matters, but the position of the Fibo you
You are right.
Yes.
You are right. Very good. And that answers your question too. We are concerned about the index and not the position as the position anyway, and not the number itself, isn't it? So and then of course from the functions you can apply several functions on the vector, isn't it? We've seen that you can apply sum, mean. There are also other ones. Length. If you want to know how many elements are there in the vector, you use length. Length. For example, this what was it? If you do len names now, length names gives you what? Gives you the what? What's happening to my code? She said as well.
The one who gets in the experience.
Okay. That's 3, no? Yes. So because there are 3 names here, 1, 2, 3, isn't it? So apart from length, you can do sum, huh? You can just.
Excuse me. I'm asking, can you also get magnitude of each parameter in vector?
Sorry?
Percentages each of
Can you
get a magnitude, that is the
magnitude
yes,
of
each of the parameter in vector. I want to know each of the parameter what percentage it so that we'll be able to know the past.
Yes, now.
In terms of what?
Yes, now you can now.
Huh?
It's asking a very simple. Okay, let me give an example.
Yes.
Let me see scores of students, isn't it?
Okay.
Is equals to, let me see, C. Somebody got, okay, let me see some numbers, 3, 5, somebody got 3, somebody got 5, somebody got 10, somebody got 22, and somebody got 4. Yeah? And you want to get this first number, how many, what percentage
Yeah.
does it?
Yes.
Yeah, you can do it now. So what does it do? What do you do now? How do you get the first number? I want to get the percentage of 3 in this number. Mathematically, you do what? 3 divided by the total multiplied by what? 100. Right? So what do? You say score of what? Of the first number. That's 1. Right? Multiplied, or they say divide by sum of scores, isn't it? Then everything multiplied by 100, isn't it? And that will give you, if you print this, that will give you the percentage of 5.55%, isn't it? The one that has the highest is the 1, 2, 3, 4, huh? 4. So that's like 40.7%, isn't it? Is that okay? Is that okay? And if you add all the percentages, what do you get?
100.
You get 100, isn't it? So how do you do that? Can you do that? Hello? Look at this. Look at this very well, please. This one, I'll give a prize to whoever does it. Wallahi, I'll give it. Even though I don't have money, but I'll give the prize.
100,000.
Scores, ba? You know scores 1. Scores 3. All over sum of scores times 100. Cool? That would be the percentage of what? Of 3, right? What of, if you do scores, so this one is for the first one, but not for 1. So that's the first number, right? For 2, isn't it? And then if I do for 3, sorry, this is 3, right? And then this is 4. And then how many are these? 5, good? 1, 2, 3, 4, 5. You know, if you add all of this together,
5, 4,
what happens? To give you 100, right?
You repeat 4, sir.
Eh?
I repeat 2.
And go. Yes, go. Nice.
So the S as scores.
I know.
4.
Okay.
The last one should be 5, sir.
Okay. 5, go. This one, go. If you do 5 here, and I call this x is equals to, isn't it? And I print x. X should be like 99.9999 or 100%, depending on. In order to avoid confusion, let me call this x1. Yeah, scores 1 divided by sum of scores, right? times 100, isn't it? Times 100, isn't it? So this should be 2. Cool? And then this should be 2. This should be 3. And this should be x3. And then this should be 4. And then this should be 4. And then this should be 5. And then this should be 5, isn't it? And then n, if you see sum of x1, x2, x3, x4, x5, oh? And then I print, no?
That's all for
x5, no? I run this. This should be 100%, no? But do you notice that I am writing? I've been copying and pasting. So can we just write a for loop that will do this for me? Who can write a for loop that will print everything for me? Huh? Yeah, because here we are doing the same thing. We are only changing 1, 2, 3, 4, 5. But we are doing one thing in a repeated way. So can we write a for loop that will just work with one of it and continuously be adding it and give me the answer to be 100%? Eh? You said? For loop. You can do the for loop or while loop.
That was the question. Advice.
But do you get the question? Let's write a for loop. Yes. That you can just drag and so maybe we can have what? Our scores. We can say our total is equals to 0, isn't it? Yes? Abi? Our total can be equals to 0. Yes? We can now say for open bracket I in 1 to what? 1 to 5 bar, because we want 1 to be 1, 2, 3, 4, 5 bar. You now said total is equals to total plus what? We now copy this guy. And then we put I here, go. And then whatever we do, and then thereafter we can print total. So this code that we've written, it gave us 100, right? How many lines? 1, 2, 3, 4, 5, 6, 7. So you can just do it in how many lines here? 1, 2, 3, 4, and you also get the same result.
For all that you have done, it's like someone needs to know what to do mathematically, not on the software, but like manually.
Of course,
you
need to analyze what will happen mathematically first.
Can R make a way out for you where you are confused or you don't have a way out? That you cannot do it yourself.
No.
Because it's a computer.
R is just a programming language. Whatever you program is what you get. It is your duty to think on what do you think will be done, so that if I do it, I get the result I want, isn't it?
Unlike SPSS, you can just do it by click and whatever.
Okay, the GUI.
Like SPSS.
Okay.
The GUI.
Yeah.
Without you even knowing how to do it mathematically,
Really, it will do for you.
these are your costs
Okay, but here you are a bit advanced now. At least it's better for you to know what you want to get than. Yes, sir.
Sir, mathematically, if you are working, you can get an error and then come back. Detect where the error is.
Of course.
So in this program, now,
Mhm.
can you do the same?
Yeah.
If we run the program and we discover that the answer is not there,
Yes.
we can go back.
National, for example, let me come and put 6 here. Or if I put 4 here. If I put 4, what will happen? It will take the percentage of 3, 5, 10, and 22 and stop. So if I run the code, I will realize that it will be less than 100, maybe 74%. I'm not, okay, this thing is not correct. You go back now and say, okay, the length of something is 5. Then you just make it 5, and then you run it again. That's all. Sorry, sir, have I answered your question?
Yes.
Or you want to add?
No.
Okay.
So why not use 6 instead of 4?
Yeah, if you put 6, it will give you error now.
Yes.
If you put 6, it will give you error because no, if you do 6, it will not give you error. Yeah, it will give you error because scores 6 will not be there. If you do scores 6, it will tell you that it's not a number, isn't it? So if you try to do score 6 plus, let's say 100, what happens? So you get not a number in return because for the first 5 you get 100, and then if it asks to not a number, you get not a number. So,
Sir, I thought total equals to 0 is a new variable you created.
total plus
This total and the value of 0 is a new variable you created.
total is equal to 0. Which one?
What I mean, name total with value 0 is not a new variable you created. So now you need to bring the first command before you do this, or if you do this that it will not, how can it remember that it's that one?
Okay. If I refuse to put total equals to 0?
What I'm saying is if you refuse to bring the first command as someone
Understand? On the way, no way.
someone. So I'm back to the score.
Scores no way.
Cost to kaza.
This code is working based on this course now. It's indexing it. It's indexing it. This course we are indexing. We are simply using the for loop because we know it can iterate from 1, 2, 3. You know, this is how we did manually. 1, 2, 3, 4, 5. But we've learned in our last class that we can do a for loop that can have a range of 1 to 5, and then in each iteration we supply in the new value of I. So in the first instance, I will take the value of 1. That will be this, what? Isn't it? And whatever it gives us, we add the value to total. Total was initialized to be what? To be 0. And then in the second instance, I is 2. It will now compute this one and add the result to the new total till we exhaust everything.
Sorry, sir.
Yeah.
We are doing a follow. Do we still need to put x2, x3, x4, x5?
No. It's just because we are together. If you are doing the for loop, this is okay. Okay? Just do this and get. So, but here is because it is 5. How can we do this using a while loop? Because essentially the while loop and the for loop do the same thing in a different way. But whatever you want to implement using a for loop, you can also do that using a while loop. How can we do this using while loop? Please, let's think. Let's open our brain and just think. What does while loop do? What do we want to change here? By either? It's either we want to change from 1 to what? From 1 to 5. So can't we initialize the I to be 1? and then write a while loop. While 1 is less than or equals to 5. You understand? So I can just come and say scores is this, right? I can now say I is equals to what? Is equals to 1. Have you? I now come and say while I is less than or equals to 5, do this thing. Have you? But if you leave it like this, forever and ever, 1 will be less than 5 now. So we need to update. We need to come here and say, okay, I is now equals to I plus what? Plus 1. And if we do this, it should give us our whole. Okay, it should not be
0, 10.
Sorry, no. Okay, 100, right? This should give us our 100. You can also sort vectors if you want them in a particular order. Okay, use 413. We stop here. We stop here. Oh. Yeah. So you can sort vectors, but if you have a vector and you just see sort, then you supply in the name of the vector and you supply in this parameter decreasing true. So it starts from decreasing order, isn't it? We've also done this now. I've treated this in for loop. If you say 3 to 9, it means 3, 4, 5, 6, 7, 8, 9, and then you can get that. I tried to do the step in R at that time, but it failed because it's not Python, isn't it? In Python, I can just come and see. I can come and see X is equals to list range. Let me see, from 10 to 100, taking a step of 2, for example. Okay. Sorry, command equal. And then if you print X now, you see 10. So the step here is talking about the steps that you take, isn't it? Yeah, 2, 2. But if you leave it like that, without any step, it does 1, 2, 3, 4, 10 to 12. But in R, you have to use this SEQ sequence, isn't it? In R, you have to use SEQ. So we can use the SEQ function to create more complex sequences that follow a given rule. The first is the starting number, the second is the last number, and then the by is the what? Is a step. Is that okay? Yes. Sec 1, 10 by 2. So it will be 1, 3, what? 5, 7, 9. Ordinarily it ends in 10. But because if we add 2 to 9, it traverses to 11. So it will not go there, isn't it? So this is an example. And then from there, from here also, you can filter. This is important to data analysis. You can filter. So you have a sequence of numbers, and you can just filter by a Boolean. So it's like you are indexing, but you are only indexing where that Boolean value is what? Is true. Okay? So in this case, if you do sec 1, 100 by 2. It will do 1, 3, 5 to what? To 99. Go?
99.
To 99, well? To 99, isn't it? And if you do that now, if you say x is less than or equals to 50, so it only prints those numbers from that range that are less than 50. Is that okay? It's okay. So you are just indexing, but you are not indexing by a value. You are indexing by a boolean. So you can index by a boolean. So this is another example. You can change the index of a number. If you do 1 to 5, it gives you 1, 2, 3, 4, 5. Well, you can now go and say, change the second index to what? 42. And it becomes 1, 42, 3, 4, 5. And then you can also add, subtract, multiply, and divide vectors, isn't it? For example, we have a vector here, v1, v2. If you multiply v1 by v2, you have 2 times 5, 6 times 3, 1 times 4, 5 times, etc. Yeah, if the length of one is a very good question. If the length of one is more than the other, R, as far as I know, takes the. Let me illustrate. Let me say C is equal x1 is C. Let me say 10, 20, 30, 40, 50, isn't it? And then x2 is equals to, let me say C, 2, 3, 4, let me say 1, 2, 3, 4, 5, isn't it? Here they have the same length, isn't it? 1, 2, 3, 4, 5. So if we print x1 multiplied by x2, we simply get 10 times 1, that's 10, 40, 90, 160, and then what? 250, go? Isn't it? So my friend is asking, what if this guy is 6, 7, 8? What will happen? It will stop and then start from the beginning again. So? It will stop here. It continues.
60, 80.
It will do 1. It will do 1 times 10, 2 times 20, 3 times 90, 4 times 40, 5 times 50, and then Dix will now start from 6. Will now start from 10. As far as I know, I don't know if it's longer now. Maybe it will not work. So they have to be of the same length. But let me try something and see. Let me say x2 and x1. So they have to be of the same length. Yes.
Count 50, 30, up to 5. And this will 1, 2, 3, up to 5. And each one has a property to multiply with. But if you say 1, 2, 3, 4, 5, 6, the 6th one has property.
Yes. But what? Let's try, because I know why I responded. What if we have 7, 8, 9, and 10? You know, when they were, x1 has a length of 5. Okay. The length of x1 is what? Is 5, huh? And the length of x2 is 5. It's 8. It did not work, isn't it? It gave us error. But in this case, if you run this one, the length of x2 is now what? The length of x2 is now 10. So if you try to do it now, I'm not sure it will not give you error. It will now start from the beginning. That was the explanation I want to, but I forgot to add that if they are not consistent, I don't know that you understand. Sir,
I don't know. Wait for him. What happened this
X1 is what? 10, 20, 30, 40, 50. 5. X2 is 1, 2, 3, 4, 5. 5. So if you attempt to do X1 times X2, everybody has a partner, isn't it? No problem. Here I now added 6 and 7. This one is now 5 and this one is now 7. If we do 6 and 7 will not have a pair. And if we start from the beginning, 6 and 7 will have 10 and 20 respectively, but 30, 40, 50 would be hanging. So R is not partial. It will give you error, isn't it? Is that okay? It will give you error. But when it realizes that we have to 10, it means that even if we come back from the beginning, each one is going to have another partner, then it's going to be allowed, isn't it? So if you do that, it's going to give you, so it will be 10 times 1, 20 times 2, 30 times 3, 40 times 4, 50 times 5, then 6 times 10, 7 times 20, 30, like that. Even if we have 10, 10, 10, 10, 10, it's also going to work, isn't it? It retorts. But the most important thing is that the division of the largest to the smallest, the length of the largest divided by the length of the smallest should be an integer. Okay. So we can add, subtract, multiply, divide, isn't it? So this is the rule. If we apply arithmetic operations to two vectors of unequal length, then the elements of the shorter vector are repeated to complete the operation. But this is incomplete with the caveat that the shorter vector must be divisible by the larger vector. Yeah, 5, 10, 15, or 3, 6, 18. Exactly. So what will be the answer here? Yes, sir. 2. Okay, let's digest it and see. A is a vector. Okay.
3 plus 2 is 5.
5. Okay, we have 2, I have 5. Another option. 5 also. 5. Okay. So let's try and see. C is a vector. A is a vector containing the numbers 1 and 2. And B is another vector containing the vector 3 and 4. We now say divide vector B by A. So X is now going to be another vector whose elements are going to be what? The 3 divided by 1, that's 3. And then 4 over 2, that's 2. So 3, 2. And when we now sum the elements of 3 and 2, we are going to have 5. Yes. So you can apply some statistical operations. Yeah, let me just conclude this. Cool. So you can apply mean, median, mode. Okay. The median is the middle value. You can apply mean, but mean will just, so you don't have to say sum this over. Okay. Yes. Okay, it's okay. We continue there, isn't it? But what I want to say is that if you have L1 here, if you want to find the mean of this guy, you can just say somewhat you can say some x1 divide by what? Length x1, isn't it? Yes? And then you can just print this. And it will give you the mean, isn't it? That's 30. But a more handy way is just to come and see mean what? Mean x1, and it will give you 30. And if you want to get the median, you can just also do 30. So we continue from here when we tomorrow.
Yes, by